Hey guys, today I'm going to show you how to solve exponential and logarithmic equations. So let's get started. The objective for this lesson is twofold. I want to show you how to solve exponential equations, and I want to show you how to solve logarithmic equations. What you have to understand at this point, though, is that, and I tried to make this point yesterday, but logs and exponentials are inverses. Okay? The same way that addition and subtraction are inverses, multiplication and division, squaring something and taking the square root are inverses. Any example of an inverse that you can think of makes kind of parallels with this. So what you'll notice is when I solve exponential equations, I'm actually going to use logs because it's the inverse. And when I solve logarithmic equations, I'm actually going to use the idea of exponentials to solve those because they're inverses. So first, let's learn how to solve an exponential equation. First, what is the solution of 15 to the 3x equals 285? Well, I've got 15 to the 3x equals 285. I want this x out of my exponent. So I'm going to go back to one of the properties that basically says log of m to the n equals n times log of m. Now, the other day in class I said that this was very, very important. This is going to be a very, very useful property, and we're about to use it right here. So basically this says if I have a log, I can take my exponent and put it out front, which is exactly what I would like to do. I would love for this exponent to be out front. So what I'm going to do is I'm going to take the log of both sides. I'm just going to go ahead and take a log base 10. The reason I would put stuff in a log base 10 is so I can use my calculator later. So this is going to be log of 285. Now I can put my exponent out front because of this property up here in the corner. Now I'm going to divide both sides by log of 15. So this log cancels with that log. So now I have 3x equals log of 285 divided by log of 15. And now I need to divide both sides by 3. So I'm going to write it this way over here because I already have a fraction. So x equals this. Now I'm going to go to my calculator, which I should have. I got it going yesterday. Okay, so good. You can see most of the calculator. So I'm going to do log of 285. I'm going to divide that by the log of 15. Hit enter. Now I'm going to divide that by 3. And I get 0.6957, so I'm going to go 3 decimal places and say 0.696. So let me pull my smart notebook back up. So x should be 0.696. So let's try it out in our calculator just to make sure we get something close to 285. It's always good to check yourself before moving forward. So I'm going to clear all this out. I'm going to say, let me scoot this over so we can see everything. I'm going to do 15 to the 3 times 0.696, and hopefully I get 15 to the 3 times 0.696. Now this better come out to be something close to 285. And I'm good. Okay, so x is 0.696. Now what I need to do here to honestly be more accurate is I need to write x is close to 0.696. Use the wavy equal sign to show that you are approximating your answer. I want to see this when you round decimals. I do not want to see this when you're rounding. But if the answer came out to be 0.696, then you would put equals. But since I rounded, I'm going to put my wavy equals. So that's how you solve an exponential. Let's look at another example. What is the solution of 5 to the 2x equals 130? So I have 5 to the 2x equals 130. I'm going to take the log of both sides so that I can get to that exponent. Pull the exponent out front. Divide both sides by, and actually I'm going to show you a little trick here. I can divide by everything I want to get rid of because this is all multiplication. So I'm going to divide by 2 log 5. So this 2 cancels with that 2, and then this log 5 cancels with that log 5. So x is going to come out to be equal to, not really sure why that happened. So x is equal to log 130 over 2 log 5. I'm going to go to my calculator and say log 130 divided by, now watch what I do because I have multiple things on bottom. I want the calculator to consider that as one thing. So I put it in parentheses. And then I hit enter. I'm going to round to 3 decimal places. So this means that x is going to be about 1.512. So x is going to be close to 1.512. Okay, remember I want to see the wavy equals when you round. So what is the solution of 4 to the 3x equals 6,000? So 4 to the 3x equals 6,000. I'm going to take the log of both sides. I apologize. I did not take the log of 6,000. So I've got both the 3x up front. Divide by 3 log 4. That 3 cancels that one. That log cancels that one. So x is equal to log 6,000 over 3 log 4. Pull up my calculator. We'll clear the screen just so there's nothing else there. Log 6,000 divided by, open parentheses, 3 log 4. Close, close. Enter. So 2.092. So x is going to be close to 2.092. Okay? So, let's work one more example. What about 7 to the 4x equals 800? So since this doesn't have the sentence, I'm going to pretend like I wrote it, basically just to be lazy. I would immediately take the log of both sides. Pull the 4x out front. Divide both sides by 4 log 7. So x comes out to be log 8,000 divided by 4 log 7. Pull up my calculator. Log 8,000 divided by, open, 4 log 7, close, close, enter. So 1.155. So x is going to be about 1.155. So that is how you solve an exponential. You basically choose the inverse operation, which is a log, and then you can solve it. So there's 4 solid examples. The exponent could be a little bit more complicated, but it's simply going to change the algebra you do after. So nothing horrible. But that's basically how you solve an exponential. So next, I'd like to show you how to use solve a logarithmic equation. And to do so, we're going to use exponentials. So let's get into an example. What is the solution of log 4x minus 3 equals 2? Now what I'm going to use here is I'm going to use this base. Okay, this is log base 10. What I said in class on Monday was that if you don't have a base written, then you assume it to be 10. So I'm actually going to make both sides of this equation the exponent to a 10. Now this is going to look funny, but in a second you'll see why I do it. So basically both sides become exponents. Okay, so log 4x minus 3 is the exponent of this 10, and this 2 becomes the exponent of this 10. The reason I would do this is when you have a log of the base, whatever base it is, that is the exponent of that same number. So this number here, this 10, has to match your base. When that happens, these will cancel each other out. So over here, I now have 4x minus 3. So I did this whole step so that my log would disappear. So now I just work it like an algebra problem. 4x minus 3 equals 10 squared, which is 100. Okay. I'm going to add 3 to both sides, so 4x equals 103. And then I'm going to divide both sides by 4, so x equals 103 divided by 4. I could simplify that to a decimal, but I don't know if it's really called simplification. So I'm not going to do that. Okay? So there's the basics of how you solve a log. Let's look at another example. Solve the log of 3 minus 2x equals negative 1. So these are going to become exponents. I'm going to show you kind of a shortcut that I used to do in high school. I used to just write my 10 here and my 10 here. So this 10 canceled that log, and I would have 3 minus 2x equals 10 to the negative 1. 10 to the negative 1 is really 1 over 10, so I can get rid of that negative exponent, and 1 over 10 is 0.1. So I'm going to do 3 minus 2x equals 0.1. I'm going to subtract 3 from both sides, so negative 2x equals 0.1 minus 3. So just for simplicity, let's go to the calculator. 0.1 minus 3 is negative 2.9. Then I would divide both sides by negative 2. So x comes out to be, let's take negative 2.9 and divide by negative 2. 1.45. Now notice I'm going to put the equal sign here because it is 1.45. It's not close to 1.45. It is 1.45. Also, typically I don't like decimal answers, but we were forced into a decimal here when we did 10 to the negative 1 equals 0.1, so just run with it. We can't avoid a decimal. We could have done 1/10 and subtracted 3, but then we would have dealt with a lot of fraction stuff. And I think that would have taken the focus away from how you solve a log to how you work with fractions. So the decimal's fine there. What is the solution of log x minus 3 plus log of x equals 1? Now, the first thing I'm going to do is I'm going to combine these two logs into 1. This is something we went over in class the other day, and since I'm adding, I can multiply the insides. So this is going to be log of x times x is x squared. X times 3 is going to be negative 3x equals 1. I'm going to make these both exponents on 10. So that cancels that. So x squared minus 3x equals 10 to the first power, which is just 10. Now this is interesting. I end up with an x squared. So what I've noticed here is, since I have an x squared, I'm wondering if I've got a quadratic here. So what I'm looking at is, first I'm going to look for 3 terms. So I've got x squared, I've got x, and I've got a constant over here, so I'm going to rewrite it like this. Okay. And I have a quadratic here. So what I need to do is I need to try to factor this thing. So let me take all of my work here, drag it over. I'm going to get rid of this arrow here just so I have some room. All I'm doing right now is creating myself some space. So now I'm going to change colors because I'm shifting gears into solving a quadratic. So let's break down x squared minus 3x minus 10. I need factors of 1 times 10 is 10. Factors of 10 that are going to get me 3 are 2 and 5. So I'll have x squared, it's a horrible squared, plus 2x minus 5x minus 10. Throwing my grouping symbols. So I get x times x plus 2 minus 5 times x plus 2. Then I have x minus 5 times x plus 2. So x can be 5 or negative 2. Now, when you end up with multiple solutions, you need to check them to make sure they both work. I'm going to imagine that both of these are not going to work. So we're going to plug these in using our calculator. I'm going to go take 5 first. And I'm going to do, well, let's clear everything out so there's no confusion. 5 store x. Now I'm going to type in my equation, log of x minus 3, close, plus log of x, and that comes out to be 1. So 5 checked out. Why is that happening? Oh, my goodness. No, don't want that. So the 5 checked out. Now let's do negative 2. So I'm going to take negative 2 store x. I'm going to use the command of second enter to bring back up what I previously typed in. And I get a non-real answer. So the 2 did not check out. So negative 2. Negative 2 is not actually a solution. So it's just 5. So when you get multiple answers, make sure you check them because one of them may not work. Last example. What is the solution of log 6 minus log 3x equals negative 2? So the first thing I'm going to do is, first let me just scratch through this. Okay. I understand the question, but I really just want to see the problem. So log 6 minus log 3x, I feel like I should combine these through division. Because I have a subtraction sign, I'm going to do log of, let's see, 6 over 3x. The 3 and the 6 will reduce, so this just gets me 2 over x equals negative 2. I'm going to do exponents of 10, or bases of 10, so these become exponents. This log cancels, so I get 2 over x. I have no idea why this keeps happening. So this gets me 2 over x equals 10 to the negative 2. 10 to the negative 2 equals 1 over 10 squared, which is 1 over 100, which is 0.01. So I'm going to multiply both sides by x so I can get the x off the bottom of that denominator. So 2 equals 0.01x. Now I divide both sides by 0.01. And that's really starting to make me angry. And so x is going to be equal to whatever 2 divided by 0.1 is. So 2 divided by 0.1. Not 0.1, 0.01. 200. So x equals 200. And that is how you take a logarithm and solve it by using exponentials. That pretty much concludes the lesson. To remind you, the things that we have done today are, I showed you how to solve exponential equations by using logarithms, and I showed you how to solve logarithmic equations by using exponentials. And the reason we did that is because logs and exponentials are inverses of each other. So one, quote unquote, cancels the other out. So I hope that this lesson helps you be successful with the material, and good luck.